Hello and welcome. Students, now we are going to discuss the new point in a mathematical logic, that is the application of logic to the switching circuit. Here, uh, application of logic to switching circuit, because in a logic we have seen a statement having truth value t or false, but not both. Same type of situation happens in a switchboard. We know in an electric current we use switches, and we all know switch having the two states, on or off. Okay, if the switch is on, the current flow through the circuit and the truth value is taken as a T, and switch is up, then current does not flow through the circuit. I am taking switch like this. There are we can show as a, this is a switch. Okay, and this switch is now in open position. Okay, if the current, and this is joined with here battery, here lamp is connected, and other wire is like this, current flow from this to this, and this is switch S1. Now switch S1 is here now open position. Okay, means from this battery current will flow up to this, but current not passing through other point because it is open in position. If we press this metal bar like this and touch here, then current from this to this will go further and will transfer like this, and the lamp will be on. Means in this condition, if we press like this, the next position will be look like here. Here is the original position, and this is now here switch S1, battery same one here, plus minus here, lamp is here. Now in this condition, switch is closed. Switch is closed. Switch is closed means what? If the current flow from this up to here and press like this here, the current will pass from one point to other point. Means this current will pass from this to this, and the lamp will on. Okay, here switch is open, current does not flow, and here switch is closed, the current will flow from one point to the other point. Same situation we can take as a this switchboard like this. I am taking this switchboard. You all know this type of switch here. Okay, now this switch is now in on position. Here is a wire is connected at one terminus, and other is here, and one wire is like this. Now in this condition, if we press here, now this position is on. On means what? Here current passing through this point will just close to other point, and current passing through one point to the other point, and the truth value is taken as a T, or it is a 1. And if the switch is closed, means like this, I am drawing like this. Now see here, now in this condition switch is now off position. In off position, now switch is off, so current does not flow from this point to other point, and the truth value is F, or here we can take as a 0. Means here switch is playing a more important role, because switch is giving two states, that is first state is on, other is off. And also we have seen in that compound statement, if the two statements are connected by AND, it is a conjunction, connected by OR, it is a disjunction. Same type of situation is happening here. Now let us see the arrangement of types of arrangement of switches. Okay, now see, if the switch is connected like this, here two switches are connected in series. Here switch S1 and switch S2 here. here is a battery, here lamp, and here again connected like this. Okay, here a plus sign, here is a minus sign. Okay, now see, current flow from this battery up to this, and this S1 is closed. Suppose this as a P, this as a Q. Let P the switch S1 is closed. S1 is closed. If S1 is closed, then and then only current flow from one point to the other point. Okay, and Q, the switch S2 is also closed. S2 is also closed. S2 is also closed. Then what? The current will pass from S1 as well as S2, and this lamp will be on, or we can say as a glow. And here L, the lamp L is what? On. Symbolic form is, here is S1 means here written P. So P, Q is here, and they are in series. Means what we have to use here? AND symbol, and this is equivalent with L. This is a symbolic form of the two switches which are connected in series form. Let us find input output table, or we can say as a switching table. Switching table, we can say another as a input output table. Input output table. Okay, here are two switches, P and Q. Okay, S1 and S2, that is P and Q, and they are connected in a series, and here is AND. Situation is here, and P and Q. And for two possibilities, here P and Q are the two different switches. So we know here both having 1 1 0 0. We have seen in the conjunction TT FF. Instead of using TT, we are going to use here 1 1, and instead of F false, we are using 0 0. So after that, here 1 0 1 0. Now see the last column. If the current flow from this battery, here S1 is closed, current will pass from one point to the other point, means truth value is T, means or 1. If say S2 is also closed, then what? Current flow from this point to the other point, means truth value is 1. And then only the lamp will glow, means here is a 1. This is truth value is 1. In other condition, see, here switch P is what? 1, means this is a closed, but this is in open condition, means 0. Current does not flow through the circuit, lamp will not glow, hence it is a 0. For third condition, check here, 0 1. 0 means what? S1 is not closed. Not closed means current does not flow through the circuit, means what? No question of S2. In this condition, lamp does not glow, means here output is a 0. Last condition, first situation 0, last is 0. This is open, this is also open. Current will come at this point, but this current does not pass from S1 as well as S2. In both the condition, here the lamp does not glow, means the last condition is here 0. Okay, and this is input output table for the two switches when the two switches are connected in a series. Same type of switches we have seen in a conjunction. We have seen conjunction. What was conjunction? Same rule. P, Q, P and Q. Here double T, double F, TF, TF. Truth table for conjunction. Listen. Now, and what was that rule? Double T, double F. Here, T is T, and otherwise, here, F, F, F. See here, observe this table and this table. This table was truth table. We can say as a truth table of conjunction, and this is a not truth table, switching table or input output table for the if the two switches are connected in series. There is some similarity between these two conditions, and this type of similarity observed by the mathematician Claude Shannon in 1930, and he has given some similarity, that is here in 1930 Claude Shannon noticed an analogy. Analogy means that is a similarity between these two conditions, that is statements and the circuits. Okay, again we can say as a for a mathematical logic, we can instead of yes, we can use a P dot with Q instead of using and replaced by dot. P dot Q is equal to 1 as well as 0. When it is 1, if P is having output 1, Q is having output 1. In other condition, they are given as a 0. Okay. Now let us see a second type of the switches. If the switches are connected in series like this, instead of using series, here I am taking as a parallel arrangement. S1 and S2, these are two switches connected in parallel. See here, S1 and S2, these two switches are in parallel form. This line is parallel to other one. S1 is same way, switches S1 is closed, S2 is also closed, lamp L is on, symbolic form. Here if the current will come from this point here, this current will pass by two ways, this above way or this below way, means this upper line or below. These are the wires, and there are two possibility, means here I am using here or, not using and. For series arrangement there is and, here or both possibility are here. Current will pass upper line or below line. Okay, and will come to this path and the lamp will be on. Now switching table and, or we can say as a input output table. Now here P and Q, they are connected in a parallel, so I am using here or. And same type of situation we have seen here, the word or is here, or is written, and means we have seen that disjunction. What was the truth table for disjunction? Just observe, P, Q, P or Q. Truth table for the disjunction. Double T, double F. Here, TF, TF. And the truth table for disjunction gives some tricks there. If FF, it is F, otherwise T. Same type of situation is here. Instead of using T, we are using here 1 1. Okay, FF, instead of using FF, we are using here 0. What is here? T. Here 1 1 1. Our last answer is 0. Now let us check this truth table in this condition. If the current will pass through above part, means wire S1, means S1 is closed. If S1 is closed, means what? Current will go from this point to other point and lamp will go here. S2 is also closed. S1, S2, P, the switch S1 is closed, truth value is 1. S2 is closed, truth value is 1 here, look here. And result is 1, means lamp will on. Okay. In second condition, S1 is 1 here written. This is closed, but this is open. Open means what? This is totally current does not pass through other line. So answer is 0. Output is 1. From this path the lamp will on. Okay. Third situation here, F is P is 0, means this is a close. S1 is open. Open means current does not flow through the circuit. And if this is totally open, this is other possibility. S1, S2 is closed. Here it is, means what? Current will pass through like this and lamp will be on. So 0, 1, answer is 1. Okay. Now see this one, last condition. 0, 0 means this is closed. This is also closed. Means what? Current will come here and will not pass through these 2 points. Means what? The lamp will not glow. Once again, repeat. I am repeating here. So these are 2 in closed position. Close means what? Current will pass through other part. Lamp will on. 1, 1. It is result is 1 means lamp will on. Second, 1, 0 means this is closed. This is open. Current will pass above part. Lamp will be on. Last, 0, 1. This is open. This is closed. Current will pass from this path. Lamp will be on. And last one, both are closed. Both are open. Means current does not pass through S1 as well as S2. The lamp will not glow. Means this is a second situation for the arrangement of 2 switches. Okay. And here in a mathematical logic we can also use here, instead of or we are using here plus. P plus Q. P plus Q, answer will be 1 or 0. This is the main important point. P plus Q, 1 or 0. For one condition here, both having 1 means both having closed, one closed, the other open. One is open, other is closed. And for 0 what? Both are open position, current does not flow. Thus we have seen the 2 arrangement, that is a series arrangement and the parallel arrangement for the switches. Now some remarkable points are, now see, so 3 points are here. First is equivalent switches. What is equivalent switches? If the 2 or more switches, if here are only 2 switches are given, but if we consider a circuit having more than 2 switches, S1, S2, S3 like that, and the more than in such a situation, if 2 or more switches denoted by same symbol, this type of arrangement that is called as equivalent switches. Okay. After that, second point is complementary switches. Complementary switches means what? If S1 and S2 are the 2 switches, if S2 is closed, S1 is open, and or if S1 is closed, S2 is open. This type of situation is called complementary switches. Means what? Here S1 and S2 are complementary switches. In complementary switches, what happen? When one switch is open, other is closed. One switch is other is closed. Means S1, and now this is arrangement, parallel arrangement. So S1 and here S2, they are connected in parallel. Parallel means OR. If here S1 is denoted by P, this is denoted by Q. Here P or Q, but this Q, instead of using Q, here this is a closed, this is open. Open means what? I am using negation of this. Just remember, I am not using here now Q, I am using negation P. P or negation P. Result is what? It is, this is P, current pass through this, close, but this is open, no question. Lamp will on. Result is what? T. Result is a T. T means what? Output is a true, means lamp will on. This type of situation is called complementary switches. What is the complementary switches? S1 and S2 are the two switches are given. If S1 is closed, same switch is operated by, same lamp is operated by two switches. One is closed, other is open. This type of situations, okay. And now we can arrange like this. Here negation P, instead of use here negation Q. S1 dash is closed, lamp L is on. Here P or negation P I am writing here. In this condition, truth value what? It is always T. Okay. Now if the two switches are connected in series, complementary switches, I am using here complementary switches. Complementary switches in series. This is S1, here S2. These are now in series, but we are using complementary. Whenever one is closed, this is closed, this is open. So S1 dash, I am not writing S2 here, S1 dash. In this condition, what will happen? Here is a battery, here is a lamp. What will happen here? This is closed. Closed means what? Current pass through one point to other point. But this is a open. This is a open. Current does not flow. This is called P. This is negation P. And here arrangement is like this. And in this condition, lamp does not flow. Means answer is here. We can say F, or we can say as a 0. P and negation P, result is 0 because the switches are connected in series. And we have seen already for parallel, if like this, here S1 and here S1 dash, not S2. See here what will happen here? Current here is like this, current will go like this. Here wire is here, battery, lamp is here. Observe here S1 is closed, S1 dash is open, negation P, or in this condition what? Always lamp will be on here. So answer is here, it is 1, or we can say as a truth value. Thus we have seen how the mathematical logic, concept of mathematical logic is applied in a switching circuit, because switching circuit gives a switching, that is switchboard, that is switch gives to on and off position. In next lecture we will see the new point related to this concept, or how we can convert the given circuit in a mathematical form, and how we can find input output results of the given circuit. Okay, thank you.